And the last talk we'll hear for today, or for this session, is from Lasair.
Hi, hopefully you can see my screen. It's Ken Smith.
Yes.
And okay, so this was again originally written as part of the kind of APIs tutorial. So you'll see a lot of familiar stuff here from what I spoke about the other day. So I'm just going to show you very briefly. This is only going to be a few minutes long. 3 different queries, all of which are looking for extragalactic objects, in particular supernovae. So let me just show you what's going on here. So as usual, we install our Lasair API. The Lasair API client library isn't required. And in fact, in the last tutorial here, we completely bypass using that library altogether. So that's installed. As before, let's grab our token. And again, what I want to show you here is just fairly free-form SQL queries done against the Lasair system. So let's just take a look at what we're doing here. This is our bright supernova type objects. So this is a very simple query. So give me everything that our context classifier has given us as classified as a supernova. Give us objects that are brighter than magnitude 19. Give us objects that have at least 12 more than 12 what we think are good and positive flux candidates compared to the reference. Just to restrict the number of objects coming back, I've said let's just restrict to objects with a label of ZTF21. And this is also partly because our prototype database here is incomplete. Doesn't contain all the data, only contains the last 3 months or so of data. Let's do our query. So again, we're using our Lasair client, and we're just calling the query option here. So let's just do that. Yes, let's do that. And just plot them. So that's all we're going to do here. Just plot what we got back. Right. Yeah. Okay. So by the way, when you run this query, it'll run differently every day. Because we're using the current time to go back to trace back how many days we're going to look at. In particular, for this next query, again, we're using the query API. So the last one used the light curves API. This next one is going to use the objects API to pull back information about these objects. In particular, what we have done is integrated a cache of the TNS onto Lasair, which means that we don't have to keep pulling the TNS. The downside of that is, of course, that the cache is only as up to date as the last time we did our caching. So we don't want to be constantly querying the TNS all the time. So as well as the light curve, we have the TNS information with these objects. So as usual, grab my token. And this time, what we want is give me the object ID, the coordinates, the minimum MTD, the maximum MTD, the minimum RMAG, the most recent RMAG, what Sherlock thinks it is. Give us the star galaxy score based on whether or not it's near a PS1 object and its own score, star galaxy score. So that's basically the explanation of the select part. And then the conditions are basically give me everything within the last 4 days. We're using a query similar to this to feed the ePesto plus follow-up Marshall, which is the NTT spectroscopy done at Lasair. Yeah, give me objects that are basically either supernova or another designation that we call as unclear, which it might be a supernova, it might be a star. Give me objects that have at least 3 candidates, at least 3 detections. And at least 2 of those must be positive flux candidates compared to the reference. Give us objects that are brighter than magnitude 20, simply because we can't follow up fainter objects than that at NTT at the moment. And again, restricted to 21 objects. So let's do that. Let's grab the data and print out what we've got from Lasair. We think these are not star-like, so we think they're extragalactic according to the criteria that we've introduced. So let's print them out and plot them. Let's do that. This has actually changed since since earlier. So there's 2 objects up here as well that don't have, these are just the latest light curves from the last 4 days, obviously. There's 2 objects up here that actually don't have a TNS entry on that, so let's have a quick look at that one. So anybody from the LSSTC and Fink or Ample want to claim that object, feel free. Here's another one. We think is a supernova. So this is literally hot off the press. It ran slightly differently when I ran it this morning. And then finally, Matt Nicol at Birmingham is looking for TDE-like objects. And again, very much, it's very much a free-form SQL query. So what I should say is that, like Fink and LSSTC, we also have a bunch of features based on information from the light curves. Go to the Lasair website to actually look at those, which features you can select out. So if you follow that schema link, for example, there's a whole bunch of features that you can take a look at in there. So let's just grab this query. So this is quite a long query. So what we want is get me the object ID, get me the color, the mean color, the latest GMAG, the latest RMAG, the latest observation in UTC, number of good positive flux detections, number of good positive flux detections in the last 14 days. Is it rising or fading? What is its Sherlock contextual classification? Its distance from the Sherlock classified host, which is different, obviously, from the Pan-STARRS host that comes with the ZTF alerts. Give me the brightest G and RMAG points. Give me the nearest possible PS1 host GMAG point, nearest possible RMAG point. Give me the color of those as well. And our where clause is also a bit messy here. It's within 1 arcsecond of our Sherlock designated host. We're looking for kind of nuclear transients. We've got at least 3 detections, and most of those are positive and what we term as good quality detections. I can't remember the criterion for those yet. Sherlock thinks it's nuclear transient or supernova. Give me the mean color is blue, or the latest color is blue. The object is brighter than 20 in R and G. It's not within plus or minus 10 degrees of galactic latitude. It's possible PS1 host mag maybe is red. So only include the ZTF21 objects. Give me the objects in the last 14 days, etc. On that. And out pops, hopefully. So that's the where clause. Send the query. So Matt here is completely bypassing the queries, just using the requests code that comes with Python. So we're totally bypassing our client library, which is perfectly reasonable. And of course, wonderfully, we now have an error. I have no idea what happened there. So absolutely no idea. Let me just get rid of that. right. So yeah, somebody's been altering some code today. Oh dear. Okay. Okay. Well, I'm not going to be able to complete this one. So I'll rerun this and get it to run properly and put the results back up on the Colab, so you can see what it came out. It's one of those situations where you run something and it doesn't run for reasons which are not fully understood. So I can't actually continue, unfortunately, in this. It's a little bit disappointing, but never mind. This is what happens. Danger of a live demo, I guess.
We're also at 10 minutes as well. So
Yeah.
anything you want to do to wrap up, or?
No, I will just say, ask me any questions. Feel free to ask in both Slack and here, and I'll fix this. Looks like somebody's made a slight alteration to the code, because I ran this literally half an hour ago when it ran. So need to coordinate here.
Well, thank you so much for all the speakers in this session. I think next we're on a half-hour break.